Volcanoes. These natural wonders are both magnificent and terrifying. Mountains of fire and fury, they are the Earth's way of reminding us of its raw power. They inspire awe and terror in equal measure, captivating our imaginations and instilling a deep respect for nature's might. Imagine standing before a volcano, its slopes rising into the clouds, a giant that has stood for millennia. Smoke curls from its peak, a constant reminder of the power that lies within, waiting to be unleashed, and then the earth trembles, a prelude to the spectacle that is about to unfold. A deep rumble shakes the ground beneath your feet, a sound that resonates with the primal forces of the earth. The air crackles with energy, charged with the anticipation of the eruption. This is the raw, untamed power of nature, capable of both destruction and creation, reshaping the landscape in an instant. Volcanoes are windows into the heart of our planet, revealing the dynamic processes that shape our world. They are ruptures in the Earth's crust, where molten rock, ash, and gases escape from the fiery depths below, a glimpse into the Earth's inner workings. These eruptions, while destructive, are also a vital part of our planet's evolution, creating new land and renewing the surface. They have shaped our continents, our atmosphere, even life itself, playing a crucial role in the Earth's history. Volcanoes are found all over the world, on land and beneath the sea, each with its own story to tell. Some lie dormant for centuries, silent giants slumbering beneath the earth, covered in vegetation and seemingly peaceful. Others are active, their fiery breath a constant reminder of their awesome power, always ready to erupt. Join me as we delve into the fiery world of volcanoes, exploring their formation, their eruptions, and their impact on our planet. We will uncover the secrets of their formation, the stages of their eruptions, and how they have influenced the world we live in. We will journey to the very heart of these mountains of fire and fury to witness their power firsthand, to uncover the secrets they hold, and to understand the profound impact they have on our planet. Deep beneath our feet, miles below the surface, lies a hidden world of molten rock and intense pressure. This is the Earth's mantle, a layer of superheated rock that churns and flows, driven by unimaginable forces. The Earth's crust, the solid ground we stand on, is not a single, unbroken shell. Instead, it is fragmented into a mosaic of giant plates, constantly shifting and grinding against each other. These plates, known as tectonic plates, hold the continents and oceans, their movements shaping the face of our planet. Where these plates meet, incredible forces are at play. Mountains are thrust skyward, oceans are born, and volcanoes erupt with fiery fury. The Earth's mantle is in constant motion, and these movements are the driving force behind the creation and evolution of volcanoes. The dance of the tectonic plates is a slow and powerful one, unfolding over millions of years. As these plates interact, they create the perfect conditions for volcanoes to form and erupt. At divergent plate boundaries, the plates are moving apart. Molten rock from the mantle rises up to fill the gap, creating new crust. This process is most evident in the vast underwater mountain ranges known as mid-ocean ridges, where new ocean floor is constantly being created. The Mid-Atlantic Ridge, for example, is a testament to the power of this process, a vast underwater mountain range stretching for thousands of miles. Convergent plate boundaries, where plates collide, are another hotbed of volcanic activity. Here, one plate is often forced beneath the other, a process known as subduction. The descending plate melts under the intense heat and pressure, creating magma that rises to the surface, fueling volcanic eruptions. The Pacific Ring of Fire, a zone of intense volcanic and earthquake activity, is a prime example of this dynamic process. Section 4. Mountains born of fire. In this section, we delve into the fascinating world of volcanoes, exploring their origins, types, and the incredible forces that shape them. Not all volcanoes are created equal. Each volcano tells a unique story of the Earth's dynamic processes. They come in a variety of shapes and sizes, each reflecting the forces that created them. From towering peaks to sprawling plains, the diversity of volcanic forms is truly astounding. Stratovolcanoes, perhaps the most iconic type of volcano, are steep-sided cones built up by layers of ash and lava. These majestic giants dominate the landscape with their imposing presence. These volcanoes are known for their explosive eruptions, sending plumes of ash and gas high into the atmosphere. The sheer power of these eruptions can alter weather patterns and impact global climates. Mount St. Helens, whose catastrophic eruption in 1980 shocked the world, is a prime example of a stratovolcano. The eruption reshaped the mountain and left a lasting mark on the surrounding environment. Shield volcanoes, in contrast, are much flatter and broader, formed by the slow outpouring of lava over time. These gentle giants spread their lava far and wide, creating vast, expansive landscapes. These eruptions are typically less explosive than those of stratovolcanoes, with lava flows often extending for miles. The slow-moving lava can create new landforms and reshape existing ones. Mauna Loa in Hawaii, the largest volcano on Earth, is a classic example of a shield volcano. Its massive size and gentle slopes are a testament to the power of slow, persistent volcanic activity. Calderas, massive depressions in the Earth, are formed by the most violent volcanic eruptions. These colossal craters are the remnants of cataclysmic events that can reshape entire regions. These eruptions empty vast magma chambers beneath the surface, causing the overlying land to collapse inwards. The resulting caldera can be a dramatic and awe-inspiring feature of the landscape. Yellowstone National Park, with its geysers and hot springs, sits atop a massive caldera, a reminder of the immense power that lies beneath. This geothermal wonderland is a living testament to the dynamic nature of our planet. Section 5. When fury finds release. The build-up to a volcanic eruption is a slow and relentless process. It begins deep within the Earth's crust, where intense heat and pressure cause rocks to melt and form magma. This magma, being less dense than the surrounding solid rocks, starts to rise towards the surface. The journey of magma can take thousands of years, moving through cracks and crevices, slowly making its way upwards. Deep beneath the surface, magma, molten rock under immense pressure, pushes its way upwards, seeking a path to escape. This process is driven by the buoyancy of the magma and the pressure from the gases dissolved within it. As the magma ascends, it can accumulate in magma chambers, large underground reservoirs, where it can remain for extended periods. As the pressure builds, the Earth trembles, a warning sign of the impending eruption. These tremors, known as volcanic earthquakes, are caused by the fracturing of rock as magma forces its way through. Scientists monitor these seismic activities closely, as they can provide crucial information about the likelihood and timing of an eruption. When the pressure finally exceeds the strength of the surrounding rock, the volcano erupts. The eruption can be sudden and violent, or it can be a slow and steady release of lava. The nature of the eruption depends on various factors, including the viscosity of the magma and the amount of gas it contains. The type of eruption can vary dramatically depending on factors such as the composition of the magma and the amount of gas it contains. Magma that is rich in silica tends to be more viscous, leading to more explosive eruptions. In contrast, magma with lower silica content is less viscous and results in effusive eruptions. Explosive eruptions are characterized by their violence. These eruptions occur when gas-rich, viscous magma is unable to release its gases gradually. The pressure builds until it is released in a catastrophic explosion, sending ash, gas and rock high into the atmosphere. Viscous, gas-rich magma is blasted into the air, creating towering columns of ash and gas that can reach tens of thousands of feet into the atmosphere. These ash columns can have significant impacts on air travel, weather patterns, and even global climate. These eruptions can be incredibly destructive, blanketing the surrounding landscape in ash and debris. The ash can collapse buildings, smother crops, and contaminate water supplies, leading to long-term environmental and economic impacts. The 1991 eruption of Mount Pinatubo in the Philippines, one of the most powerful volcanic eruptions of the 20th century, is a chilling example of the devastating power of these events. The eruption ejected massive amounts of ash and sulfur dioxide into the atmosphere, leading to a significant drop in global temperatures. Effusive eruptions, in contrast, are relatively gentle. These eruptions occur when magma is less viscous and can flow more easily. The lava flows out of the volcano in a steady stream, creating rivers of molten rock. Runny, less viscous lava flows out of the volcano, creating rivers of molten rock that can extend for miles. These lava flows can destroy everything in their path, but they move slowly enough that people can usually evacuate in time. These eruptions, while less immediately destructive than explosive eruptions, can still have a significant impact on the surrounding landscape. The lava can alter the topography, create new landforms, and change the course of rivers and streams. Kilauea, a volcano on the Big Island of Hawaii, is famous for its effusive eruptions, which have been ongoing for decades. The continuous flow of lava has created new land and reshaped the island's coastline, demonstrating the powerful and transformative nature of volcanic activity.